So let's think about two polynomials at once. Let's think about these two polynomials here, f of x and g of x. F of x equals x, g of x equals 3. Mentally, identify a point. So identify a coordinate where the graphs of those two functions intersect. Well, y equals 3. That's a horizontal line up at 3, right?
Yeah.
Y equals x. That's a perfect diagonal line that goes through the origin. Okay? Think about where those graphs meet. 3, 3, right? Or just think about it mathematically, algebraically. I know that this graph passes through all coordinates that have a y value equal to 3. This graph, in order for y to equal 3, x would have to equal 3. I'd have to plug in a 3 for x to get a 3 for y. So 3, 3 is a coordinate on this graph. 3, 3 is a coordinate on that graph. The coordinate where these two graphs intersect each other would be 3, 3. Okay? Hopefully we were able to do that a little bit. Next one. Where do those two graphs intersect? Or what coordinate would satisfy both sets, or both polynomials? What coordinate or coordinates would satisfy both of those polynomials? Negative 3, comma, nope. Negative 3, comma, 0.
Positive 3.
Positive 3, comma,
0.
0. Yep. Negative 3, 0, and positive 3, 0. This graph is a horizontal line at y equals 0. So it's the x-axis basically, right? This graph would be a line that's going right along the x-axis. Where does this graph cross the x-axis? At negative 3 and positive 3, right? So that's why the two solutions to this one would be negative 3, 0 and positive 3, 0. All we're doing is figuring out where these graphs intersect each other. We're trying to do it mentally here. Okay? Any questions so far? How about this set of two polynomials? Where do they hit each other? One should be easy.
3?
3, comma,
No. 3. Oh, wait, 3, 3, correct? No.
if I plug in 3 for x, what is the y value on this graph?
Oh, wait, I'm looking at the
0, right? This graph passes through the coordinate 3, 0. Doesn't this graph pass through the coordinate 3, 0? It would not be 6, 0 because this graph does not hit the coordinate 6, 0. This graph would hit the coordinate 6, 3. Because if I plug in 6 for x, out comes 3 for y. But does everybody see how both graphs pass through the coordinate 3, 0?
Yes.
If you plug in a 3 for x, out comes 0 for y. If you plug in 3 for x, out comes 0 for y. Yeah?
Yes.
Okay? I would be shocked if you could get the other one mentally. Some. Okay? In order for this value, in order for this y value here to equal this y value here, this factor would have to equal 1. Because whatever number I decide to plug in for x, I'm going to get the same answer here and here, but then this answer needs to be multiplied by some number. Well, if that number's 1, then it would still be the same. So -2 would be the correct x value. Okay? That's a little bit challenging, but what's -2 subtract 3? -5. So this graph passes through the coordinate -2, -5. This graph will also pass through the coordinate -2, -5. Because what's -2 plus 3? 1. What's -2 minus 3? -5. What's 1 times -5? Still -5. So -2 comma -5 would be another place where those two graphs intersect. Okay? And last one to do mentally, where do those graphs intersect? Or do they? Where do those graphs intersect? Or do they? Correct. They do not intersect. Okay, there is no way those graphs will ever intersect. Think about it. Distribute this out. What's this equation simplify to if you distribute it out?
X squared
X squared minus 25. So that's a parabola that's been shifted down 25 units. What's this one multiply out to make? X squared minus 9. So that's a parabola that was shifted down 9 units. They'll never intersect. Because they look exactly the same. One's just always lower than the other one. So they'll never cross. Okay? Those would never hit each other. So that's just kind of thinking about a little bit graphically what we'll be doing today. Alright? You can always use a graph to see where they intersect, but I want to be able to teach you how to do that without having to graph it all the time. Okay? Alright. Ignore this up here. We're going to do these four together in our notes. Okay? For each pair of polynomials given, find all points of intersection of their graphs. Okay? If I want to know where these two graphs intersect each other, I want to know where they are equal. So really, I just want to know where does C of x equal the same thing that D of x ends up equaling. I want to know when this function equals this function. So I want to know when this equals this. Well, C of x is really x squared minus 7. And D of x is really just the number 2. So I really want to know when does x squared minus 7 equal 2? Well, solve that equation. How do I solve this equation? Add 7.
and then
Square root both sides, and you get x equals either a positive or a negative 3. So that means your coordinates will be 3 comma something and negative 3 comma something. Because again, we're finding the point. We're finding the coordinates of intersection. If I know the x value, what can I do to find the y value that goes with it? Plug it in. Plug this in for x, right? What's 3 squared minus 7? 2. Let's take negative 3, plug it in. What's negative 3 squared minus 7? 2. Also 2. These would be the two coordinates where those graphs intersect each other. Which it should make sense. X squared minus 7 looks something like this, right?
Yes.
Y equals 2 looks something like this. You got a parabola, you got a line. Good chance you got two places where they meet. That make sense? Visually?
Yep. Yes.
Okay. Next one gets a little more challenging. Number 2. I want to know when f of x meets g of x.
just like. Just.
You should be able to get one of the answers mentally, right? If that's maybe what you were saying.
Cool. X squared. No.
That's how I'm going to show my work. I'm going to distribute it out. I'm going to do exactly what you're kind of saying about doing. But I am saying that I think some people could maybe even identify one of our answers already just by looking at it. You see some common factors.
Yes.
The x minus 4 on both sides, right? So that tells me that if I plug in what number for x, I'll get the same answer on both sides. 4. If I plug in a 4 for x, in both functions, I get a y value of how much? 0. 4 comma 0 is definitely one of the locations where this graph meets this one. This graph passes through 4 comma 0. This graph passes through 4 comma 0. So 4 comma 0 is definitely going to be one of them. I can tell that because they both have an x minus 4 as the function itself or a factor on either side. Okay? Now, there's two ways that a person could find the other one. In this instance, I could divide both sides by the common factor. If I divide this side by x minus 4, what do you get? What's anything divided by itself? 1. If I divide this side by x minus 4, the x minus 4's cancel, and all that's left is what? X plus 7.
So then you subtract 7.
And you get x equals negative 6. And then if you want to know the location of where they intersect, you know the x value is negative 6. Plug that back in to either g of x or f of x. Plug negative 6 back in for x. See what you get for y.
Negative 10.
Negative 10. Good. Plug negative 6 in for x. Negative 6 subtract 4 is negative 10. So this would be one of them. And then like we said before, 4 comma 0 would be the other. Those would be the two locations where those graphs intersect. Okay? I divided both sides by x minus 4. I divided both sides by the common factor. That's how that x minus 4 disappeared, and I just had x plus 7. It disappeared because anything divided by itself is 1. Okay? That would be one way to do it. Here would be the other way. And Caden was doing it. He was distributing. So x squared minus 4x plus 7x minus 28 equals x minus 4. Combine like terms. Then I'm going to move everything onto one side. I'm going to get everything onto one side. I'm going to get it set equal to 0. So I'm going to subtract x from both sides, and I'm going to add 4 to both sides. I'm going to subtract x from both sides, and I'm going to add 4 to both sides. Subtract x would give me 2x. Add 4 would give me negative 24. And then that's an easy factor. What multiplies to this and adds to this?
6 and 4.
Negative 4 positive 6.
Okay, good. So then x would equal negative 6, x would equal positive 4. So I'd get negative 6 comma whatever and 4 comma whatever, which again we know that when we plug a 4 in, 4 minus 4 is 0. When we plug a negative 6 in, negative 6 minus 4 is negative 10.
Dang.
So you get the same answer that way. Okay? Took a little more writing out, yeah. Yep. Okay? Why don't you guys try 3 and 4 on your own in your notebooks? Why don't you guys try 3 and 4?